Welcome to Setting Course, an ABS podcast, where we're charting the future of the marine and offshore industries. I'm Brad Cox, and I'll be your host today. We've discussed ammonia as a marine fuel on this podcast before. In that episode, we took a deep dive into production processes and using ammonia in two-stroke and four-stroke combustion engines. However, combusting ammonia has its drawbacks, especially related to nitrous oxide emissions. Amogy is a company that's developing an ammonia cracking technology that expands ammonia's potential as a fuel. In fact, Amogy is putting their technology to the test with an historic tugboat, retrofit with an ammonia-powered system. And I love the name of this boat, the NH3 Kraken. Here to discuss the technology and the NH3 Kraken is Jan Chow, Amogy Senior Manager of Applications and Service Engineering. Thank you for joining us today, Jan.
Absolutely. Thank you for having me. I'm really excited about the discussion today.
And also joining us is Michael Kei, ABS Vice President of Technology for the Americas region. Thanks for being here, Michael.
All right, thanks for having me. Definitely an exciting topic to be discussing today.
So Jan, let's jump right into it. How does Amogy's ammonia cracking technology work, and what are the advantages of the system?
So ammonia cracking is different from ammonia combustion. Ammonia cracking is basically breaking down the ammonia into hydrogen and nitrogen. So that's what our technology does. It's different from combustion, where we directly burn the ammonia. Our technology decomposes the ammonia into a nitrogen-hydrogen mix, which we then send into a absorber system to remove any residual ammonia from that stream. And then the hydrogen that is produced is sent down to a proton exchange membrane, a PEM fuel cell. The hydrogen is then consumed by the fuel cell to produce electricity and a deionized byproduct of water discharge. And the nitrogen, which is already in the atmosphere, is just vented to the atmosphere safely. Our core technology is effectively cracking ammonia. The hydrogen can be used in hydrogen engines, in fuel cells, dual fuel engines, and pilot fuel for other engines like ammonia engines, for example. So we're quite versatile. Our Amogy secret sauce is our proprietary catalyst, which allows our technology an advantage to be able to accomplish cracking at a lower temperature than others. That means we use less energy to crack ammonia.
So where does that energy come from?
Yeah, that energy comes from an electric heater that is powered by a battery system or from shore power. We use the electric heater to bring the reactor up to temperature and then combust the hydrogen product to provide our own heat to continue auto-reforming. Again, our reactor operates at a lower temperature than a typical cracker, and so our consumption to get going is much lower. We've demonstrated our technology in 3 demonstrations thus far and 1 that we're working on right now. The first demonstration was a 5 kilowatt drone, and this was a drone that was actually flown for about 4 hours or so. If you know anything about drones, they probably last about 15, 20 minutes. So this was a huge achievement for us. We also retrofitted a tractor with a 100 kilowatt system, and we ran it on a private farm. And then we also retrofitted a Class 8 semi-truck with a 300 kilowatt system. So we basically took out the motor and the engine of the truck, and we replaced it with our ammonia tank, with our cracker system, the absorber system, fuel cell system, and a battery system. And then we actually demonstrated technology on a private track. And now we're working on basically a tugboat. So this tugboat is in the Hudson River. It was built in 1957. That is currently now being retrofitted for a demonstration of our technology. A bit of history of the boat. It was one of the first, if not the first, diesel-electric vessels in the Hudson River. So it has quite a bit of history behind it, and we're now applying it for the first ever ammonia-powered vessel in the region and the world.
So with your demonstrations, you obviously use a fuel cell, which is traditionally used for generating energy from hydrogen. And of course, that's what cracking does, is it pulls the hydrogen molecule out. So why, use ammonia in this scenario instead of just using hydrogen?
Well, storing hydrogen is quite difficult. You can either have pretty large tanks at low pressure, or you have large tanks with high pressure that you run into hydrogen embrittlement issues. The energy density of ammonia is about 40% higher than that of hydrogen, which means you can have a much smaller tank. On top of that, the boiling point of hydrogen is negative 253 degrees C versus ammonia, which is negative 33 degrees C. And that basically on itself is a huge challenge, because if you're trying to transport hydrogen on its own, you really only have 3 choices. You can use a carrier, you can use a liquid organic hydrogen carrier, which is more of an oil-based, carbon-based system. So the production of that on its own already creates CO2 emissions. Or you can use liquid hydrogen, which forces you to impose a very high energy cost to keep it liquid. And that on its own, even the energy density out of that is not comparable with that of ammonia. Ammonia basically can transport 121 kilograms per cubic meter of hydrogen as a carrier. Liquid hydrogen in its liquid state is only 71 kilograms per cubic meter. So there's a huge benefit to using ammonia just because it's easier to store than hydrogen and makes it more viable to be placed on the vessel.
In addition to what Jen mentioned, we also need to look at infrastructure. The infrastructure for the ammonia industry is well established, and transportation and storage is basically there. For hydrogen, no, it's non-existent at the moment. And furthermore, ammonia can actually be produced through a renewable source, and through the reformer technology that Amogy is actually working on, we can actually get a high concentration of pure hydrogen to be used in the fuel cell technology to power the ships.
It's interesting. So, as this technology becomes more available, how does that position ammonia against other potential fuels in the marine industry? Obviously you have the tugboat in the works, and you've shown, it's scaling to different projects, different sizes. But how does that scale for a large ship? What's possible for the large ships?
Yeah, and I can answer the first question. Basically, ammonia is a mid to long-term alternative fuel. The potential for that is best realized in that terms. We do need to account for the additional challenges for using ammonia as a fuel on vessels, which is why some of the target vessels are for ammonia carriers. We can see it scale for larger vessels. We've learned a lot from our tugboat demo. There's been a lot of lessons learned about the safety mitigations required to make the vessel safe. That includes the use of double wall piping, high rates of ventilation, management of hazardous zone and toxic zones. And all that is basically needs to scale with the vessel itself. So as you get to larger vessels, the auxiliary systems that will be needed to support the Amogy systems will also have to scale in size. That said, a lot of these auxiliary systems already exist on vessels that are maintaining and carrying ammonia to begin with. So to support larger vessels, our technology scales as well. Our current design is to deploy our product as a modular unit and scale to larger power scales with more units. We're improving on our energy density as we speak.
So, of course, you're talking about scaling ships, and that makes me think of the AIP that ABS awarded for a very large ammonia carrier that's being developed by Amogy, HD Hyundai, and Capital Gas. So can you guys provide some insight into that project?
This project is about outfitting a VLAC equipped with 1.6 megawatts of auxiliary power provided by Amogy's technology. This is intended to be installed in the open deck. As you said, we're working with various partners on this project. ABS, Hyundai Heavy Industries, Capital Gas, and Liberian Registry to design this vessel. We all participated in a ABS-conducted hazard where safety risks and mitigations for the Amogy system and the vessel systems supporting Amogy's technology were discussed. And we discussed basically how Amogy's system interacts with the ammonia tanks, the feed system. We discussed the procedures to follow venting and purging while maintaining hazardous and toxic zones, how power output is being managed, just to name a few topics. And then ABS and Liberian Registry issued AIPs for the vessel design in early June.
The interesting thing about this concept is that of using an ammonia carrier provides a unique and innovative approach to energy use and conservation. This ship, already equipped with substantial supply of ammonia, has the potential to revolutionize fuel consumption patterns. The onboard ammonia itself, traditionally used for other purposes, can be repurposed as a fuel to use the Amogy system. And this is not only diversifies the type of fuel that can be used on board, but it also provides significant reduction in dependency on others, often more expensive or less environmentally friendly type of fuels. Moreover, the existing infrastructure designed for the storage and transportation of ammonia can be utilized to support this new function. This means that the transition of using ammonia as a fuel source would not require extensive retrofitting or additional investment that will be needed. The infrastructure that's already in place on board the ship can be leveraged effectively, making it slightly a more cost-effective solution. This approach could potentially lead to a substantial cost saving and making operations more economically viable.
Looking more broadly at the industry, as we've kind of moved towards decarbonization, a lot of the industry has been leaning into LNG and methanol. And a big reason behind that is that they're available, the technology's ready. But it seems like ammonia is gaining some ground here. Obviously there were several announcements about new ammonia-powered ships over the last year. So, Michael, what's the status of ammonia as a fuel for the industry at large? And, what are going to be the hurdles to more adoption?
The way we see it is adoption of ammonia as a marine fuel is anticipated to be a significant step towards achieving the zero carbon emission target set by IMO. Owners, operators, OEMs, designers, and many other innovative partners that we have in the industry like Amogy is currently analyzing the global fleet and creating new technology so that we can move forward with the construction of more efficient vessels that actually utilizes ammonia as a fuel. Concurrently, fuel producers, port authorities worldwide are also investing in green ammonia production facilities and bunkering infrastructures. Some of the significant trends that we are seeing is technological advances that is aimed at addressing safety concerns and implementation challenges of using ammonia. For example, it's like leakages, development of engine technologies, relevant fuel supply systems, and there are a lot of industry collaboration aiming at discovering what we do not know. We have been transporting ammonia for a very, very long time, but actually using it, mass usage of it as a fuel is still relatively new. So we are trying to leverage on what we know from the past and try to understand what we actually do not know. So when discussing about the hurdles of adoption, it is crucial for the industry to actually recognize that for any new technology or any new fuel, besides understanding its benefits, which I think we know very, very well, we also need to address associated challenges. So knowing what we do not know would be an essential step to actually seeing ammonia being used as a predominant mainstream fuel.
The known knowns, known unknowns, and unknown unknowns. It's one of my favorite quotes. And Jan, from Amogy's perspective, what are those hurdles that are going to have to be overcome?
Yeah, definitely. As a technology company, we see most of our hurdles coming from the risks of toxicity and the perception of toxicity. As Michael said, we've been transporting this for years. We've been handling ammonia for years. We've been using ammonia for agriculture for over 100 years. Ammonia is the second most commonly produced chemical in the world, so it's everywhere. It's on ships right now. We use it for NOx scrubbing. We use it for carbon capture. The presence of ammonia on vessels is not new. So one of the hurdles to really overcome is definitely perception that we don't have experience with this. That said, I don't want to downplay the risk of toxicity. Toxicity is a very real risk. However, there are technologies and regulations now that manage the handling of ammonia as cargo. These technologies are improving and will be adopted to help further mitigate toxicity risk. We experienced this during the tugboat. We have to apply double wall piping for any kind of fuel gas supply and for hydrogen. That is well documented by the standards in IMO, understanding the space pressures and et cetera. That is already existing. We understand some of the venting concerns. They are, I think, a little bit more conservative concerns regarding toxic material for venting. Nevertheless, I think that will be reeled in as deployment increases with more pilot projects, more data we collected. And then you have basically any kind of a release, either through emergency or anything like that, that needs to be understood. And that is also done with gas dispersion studies and new technologies to either capture the ammonia that's being released or to burn it or whatever it is, just to mitigate the risk and the concentration coming out. So the perception of toxicity and the risk of toxicity is, I think, the first hurdle to overcome. Definitely training is going to be important. And as I said, there are people who have been trained on handling ammonia, so we need to build upon that training for ammonia as a fuel. There have been several partnerships that we at Amogy have been participating with. So the Maritime Port Authority of Singapore and other collaborators, including Amogy, are developing the Maritime Energy Training Facility to train maritime professionals in operating ships powered by alternative fuel systems. That includes ammonia. And we also collaborated with ABS on the first advisory for ammonia bunkering. So I think the industry is moving in that direction, and the understanding of how toxic this material is also improving.
Yeah, so I'm glad you're talking about the safety and ways we kind of mitigate those risks. Michael, obviously safety is a key part of the ABS mission. So what have you seen from the industry at large, when it comes to the safe handling of ammonia and implementing it as a fuel?
I think what ABS is currently focusing on is, as Jen mentioned and what we have been discussing, ammonia is definitely highly toxic to humans and the marine life. Once it's released, it can have serious consequences. Even though ammonia is it's not a low flash point fuel, they are also having explosion and fire risk. There are a lot of recommendations on how to actually handle them in terms of mitigation measures, safety precautions. Those are actually all available since day one of how we actually starts to transport ammonia. They are definitely there. But when it comes to handling it as a fuel, where the leak source can be slightly closer to humans, and also there could be more leak sources, From ABS point of view, we are trying to figure out of ways to accurately understand where the hazardous zones is. Because from other hazardous fuel or chemicals, we do know how to actually quantify what's the hazardous zone. Right now with ammonia, is the dispersion zone is relatively unknown. At the moment, it's still a lot of research is ongoing. And from ABS point of view, we are working with a lot of Institute of Higher Learning, and Texas A&M is one of them, where we actually partner them to research and study on mitigation of accidental release of ammonia, what we're actually going to do and how we're going to analyze them. So from an industry point of view, I think ABS is trying to look into, again, going back to what I mentioned earlier, look into what the unknowns that we do not know about using ammonia as a fuel, and having a better understanding of how to actually maybe not control them or mitigate them, but at least understanding how they behave, so that we can work with the industry to come out with better mitigation measures or technologies to handle them or avoid such issues.
You're talking about the dispersion of ammonia and, the leaks and stuff. That's going to be the big concern. What are the regulations and what is like a safe, dispersion amount, and how that actually kind of, fits into the approach to mitigate those risks?
The regulations, at least for maritime purposes of ammonia release, is to be lower than 25 ppm. If you were higher than 25 ppm, you would have to maintain a toxic zone. If you were lower than that, because of a technology that exists today that can reduce the amount of ammonia being released, then you don't have to maintain a toxic zone. Technology is in an SCR, in a selective catalytic reduction system. The end step, especially if they're using ammonia already, is to remove the ammonia that they just used. So that already exists, and ammonia engine manufacturers are applying this SCR system, and an ammonia release mitigation system that is going to basically reduce the amount of exhaust, the amount of ammonia in their exhaust, to lower than 25 ppm, and therefore they avoid having to maintain such a zone. For emergency releases for purging, if you've had a problem with your system and you then have to use nitrogen or some kind of inert gas to shoot everything out, that's the biggest concern that we have, and that's where the gas dispersion studies start to come out. Because then your content is actually being inerted and diluted by the nitrogen, so you will overall be trying to reduce the percentage of ammonia concentration in the air. So I think that's, as far as how we understand this, technology improvements will help with mitigation of release, uncontrolled release, emergency releases, controlled releases, and planned releases. So these are the technology advancements are coming. They're already here. Most of them are actually here. They're just looking for testing. They're looking for areas to do pilot testing, to apply them on vessels and gain permission basically to actually run it.
So, obviously we've discussed where ammonia stands today, discussed its near-term outlook, as the new technologies become more available. But, what's the long-term outlook for ammonia? With hydrogen, maybe even nuclear being in the cards for the future. There's going to be a lot of different fuel and energy options, but where does ammonia fit in that? Are we looking at specific types of vessels, or is it going to branch out to be a big percent of the fuel being used? What are we expecting?
So I think the industry is seeing a lot of potential with ammonia as a fuel. It is, as you know, a conservative industry, but it's been through an energy transition before, and we definitely can do it again. We see a mix for different solutions in near and medium long term, and ammonia's share in the overall fuel, the bunker fuel mix, could rise to over 40% by 2050. According to Commodities Insights' recent forecast, ammonia could be the most common type of marine fuel by volumetric terms in 2050. But that only kind of works if you have early adopters of this technology. We need to collect the data. We need to learn more about the risks that are involved, and for regulations to also catch up, because we gain more information about how the ammonia is being used as a fuel. Definitely in the short term, I think the easiest vessels to apply this technology to is for vessels that are already carrying ammonia. So they will already have a lot of the safety systems for handling of ammonia already on board the vessel. When we do either retrofit or new build from these types of vessel designs, the jump to using ammonia as a fuel is not quite as large.
We actually agree, Jen. Although ammonia is currently not utilized a lot in the energy application, it has started to gain momentum. We expect it to become a mainstream fuel in the key renewable energy sector. But projections for future ammonia demand in energy application actually varies quite widely. Jen mentioned about 40%. If you ask another person, they will give you a different percentage. And why is that so? Is because of uncertainties in the market, in future policies, market adoptions, The extent to which ammonia is integrated into all these applications will rely heavily dependent on climate-related regulations and changes that will be forthcoming. Moreover, the development of low-carbon ammonia, basically green ammonia, will also play a crucial part in determining how much of ammonia percentage in terms of the overall fuel mix. Public perception as well plays a crucial role in transiting towards ammonia-based economy. Rural areas are more acceptable to ammonia as a fuel, whereas the urban areas has a perception that because of the toxicity and the high density of human populations, those are usually more to be avoided. So a lot of the announced ammonia projects, although they might not come online immediately, but we do foresee that a lot of them will gradually come online in the next 5 to 10 years. So based on the current market analysis, we do agree that the fuel mix come 2050, it will make up primarily of ammonia, hydrogen, and methanol as fuel, which is going to be a hydrogen-based fuel mix.
So I think to kind of add to what Michael's saying with regards to green and blue ammonia projects and the production of green and blue ammonia, ammonia production typically uses the Haber-Bosch process, and it's the same process that exists for over 100 years. It's very energy intensive. But there are a lot of green and blue ammonia projects that are upcoming. They've gotten the final investment decisions and getting finalized around the world. Over 20 million metric tons annum of blue and green ammonia projects have achieved at least partial funding to date. 6.5 out of that 20 of those projects is set to begin production in 2027. Over 200 million metric tons per annum of clean ammonia projects have been announced with production timelines between 2028 and the early 2030s. So we expect that ammonia production will be clean. 90% of ammonia production will be clean by 2050, and 60% of that will be used for fuel. We are going to see a full clean solution where we know that we're not necessarily relying on gray ammonia to power our own vessels.
Right. And that's, obviously part of the discussion when we talk about, well to wake being now a requirement for net zero. So as we're getting, near the end of our time here, I wanted to give you both the opportunity to offer some closing thoughts on our discussion.
Sure. Yeah. I think for Amogy's standpoint, we recognize that our technology is new, but ammonia is not new. Ammonia toxicity, we understand it today, handling it as cargo. We know how to safely handle ammonia. We've been doing it for several years already. It's been used in agriculture. The infrastructure and supply chain exists for ammonia as cargo, and the rules and standards around ammonia as a fuel and for ammonia bunkering are being updated today. So we see a bright future for ammonia from a regulatory standpoint and from a risk standpoint. Ammonia is also the most cost-effective zero-carbon fuel, and will have a large piece of the alternative fuels pie in the near future. We believe that Amogy's technology has advantages over directly using hydrogen and ammonia combustion. With ammonia combustion, we don't produce any NOx, or rather we produce no NOx, but ammonia combustion produces NOx. Over directly using hydrogen, ammonia infrastructure exists. It requires an easier and smaller storage than hydrogen tanks, and it's also just more energy dense than hydrogen. That said, the technology won't work if nobody adopts it. So we do need a lot of partnerships with industry leaders and with regulators, as well as class societies such as yourselves. It's really key to the success of bringing ammonia to the industry as a fuel.
So, Michael?
Yep, certainly. To navigate all the trends and overcome hurdles, we will definitely require continued collaboration, innovation, and strategic investments from all stakeholders involved in the maritime industry transiting towards a sustainable fuel such as ammonia. We need to be mindful of the challenges involved in its application and incorporating acceptance by the general public and other stakeholders to make ammonia one of the mainstream fuel in the coming future.
Okay, great. Well, thank you both for joining us today. Special thanks to Jan and Amogy for being part of this episode. And hopefully in a few years, we can have everybody back to talk about where things are, maybe 2030. We'll put you on the clock. We'll bring you back in to see where things are.
Sounds good. Looking forward to it.
And for all our listeners out there, thank you for joining us on Setting Course. If you liked this episode, leave a review, share it with your colleagues, and give us a follow. To learn more about ammonia and other alternative fuels, visit us at www.eagle.org. Thank you for listening.